Okay, now we'll talk about the thermohaline circulation. So what does thermohaline mean? Again, composition of Greek words. Thermos is related to temperature, and haline, as in halo, related to salinity. So thermohaline circulation is the circulation in the ocean that is driven by temperature gradients and salinity gradients. Topic 2 from the previous video. Now, this circulation is really important for everything that's not just a surface process, right? So in the last video we saw that the very surface of the ocean is determined by wind momentum input that drives ocean currents in the top 100 meters or so. Everything else is determined by the density structure of the ocean column. And we will analyze that in the context of the Atlantic Ocean, mostly because the Atlantic Ocean is dynamically the most active, especially the North Pacific is nothing much in terms of circulation is happening there. So first of all, we'll look at a meridional profile of the Atlantic Ocean. And so here in the south you have Antarctica. Here in the north, so this is south. In the north you have the Arctic. And I'll draw a so simplified bathymetry here. Here we have the equator. And so there are different water masses, and I will sort of delineate these. So in the lower latitudes we have the warm salty waters near the surface, and let's color those in red. And sort of typical for this is the Gulf Stream. And the Gulf Stream is warm and saline. And since this is the lower latitudes, even though this is quite saline, which would make the water dense and lead to its sinking, it's mostly just warm, and for the warmer temperatures, the temperature really is the important part for the density. So this warm water sits up top in the Gulf Stream, and it moves northward. Now, in the region here, near the Arctic, in the North Atlantic, your water becomes cooler. And now it's cold and saline, which makes it really heavy. So it starts to sink. Another effect here that happens is when you have sea ice formation, you get brine rejection, meaning as sea ice grows, it doesn't incorporate most of the salt, so you get a very salty layer underneath the sea ice that also drives formation of really dense water and deep convection. So you have this cold North Atlantic deep water that sort of sinks down here and occupies something like this region mostly. Since it's cool, let's draw this in blue. So this is the North Atlantic deep water. And a very similar process you have in the Antarctic. So you also here have cold and saline water being created. And that sinks deep and takes up actually a lot of the very bottom water in the Atlantic. So this is called the Antarctic bottom water. And that has a lot of volume actually, because in the Antarctic here you have really vast regions of ice growth in the fall and winter times. So you have a ton of production of heavy saline water. And the rest of the water column here is typically referred to as the intermediate water, and doesn't actually play that much of an active part in the circulation of the Atlantic. And that raises actually an interesting question, namely where does the upwelling happen? If we have this creation of lots and lots of heavy downwelling water, that must be balanced by upwelling. And the answer to that is not that trivial. Some of it is mixing upward here throughout the intermediate waters. There you have some sort of mixing, and then you have upwelling at the boundaries, as we've discussed in the previous video. And quite a lot of the upwelling actually happens in different oceans, not the Atlantic. And that brings me to the point that the global ocean circulation is a rather complicated 3D problem. And so the meridional picture, as we've drawn it up here right now, is rather incomplete.